possible to replicate a surveillance system that's working well somewhere. Any new installation will be different from the previous, and the differences between the two have been observed to be proportional to their scale and, when all is said and done, to their implications in VTM. Thank you.
Okay, thank you, Francisco, for sharing those lessons learned on VTM. Our next speaker is Dirk Eckhoff. Dirk is an electronics engineer who specialises in control systems. For the past 10 years, Dirk's worked as a systems engineer for the Traffic and Telematics Division for the German Waterways and Shipping Administration's North and Northwest Directorates, where he has responsibility for the technical management of VTS systems. Dirk brings this considerable expertise to the VTS Committee Working Group on VTM. Thank you, Dirk.
Thank you. So, this equipment. I want to thank all those who make it possible for me to stay here, to stand here, and say thank you to all the audience who are still that curious to want to hear and see my presentation. I have to hurry up, Chairman says, so I won't tell my 5 minutes joke right now and go directly into the VTM requirements. How to react to VTM requirements by electronic means? That's a good question, and the first question I got with that was, what are VTM requirements? So I took a look on the processes in the VTM, in the maritime domain. And we can see, okay, we have quite a bunch of stakeholders there, and a lot of processes which acting, reacting, interacting with the vessels, with the traffic, and with the stakeholders among each others. So, taking a look to it, and we heard that earlier, we have the VTM concept. These processes, pretty sure, have to be harmonized, and technically that means we have to link these processes to make a proper VTM. We need some arrangements among the stakeholders, but that is not the business of the engineers, and I'm lucky I'm not too much into that, so I can just go to the next slide and take a look on what all these VTM processes may be. I made some application examples. So right now, to make these applications run, we need some electronic support. And therefore, we take a look on one of these processes. And if we take a look on these process, one example, one of the application examples, we can see it has some generic functions. These generic functions are sensors and vessel communications, data processing, and data presentation. And almost most important, third-party data input-output. That means the link to all the other processes which have to be connected. These applications we have to bring into a system to support VTM. It's very easy here on the slide. We just make some boxes and put the function to these boxes. Technically wise, it's a bit more of work. So right now we have one of our applications brought into one system. But what we had in the beginning, we have some more of these applications. So if we right now say, okay, every application has its own system, we end up in a technical mess. Because we have lots and lots of interfaces, and we have double use or multiple use of the same data in various systems. So what we better can do is we put these functions into one system, and I did it here on the slide. We have the sensor communication functions, the data processing functions, the data presentation functions, and the third-party data I/O functions. Right now, we can see already on this image here that there is some overlapping. So we take a closer look from the engineer into these, and we figured out that the application may use the same technology or the same systems, like radar, AIS, VHF communications, to provide or to support the VTM requirements. So, since these are all different technology, we put it up in different systems. But not only that, we say, okay, make it a service. What does that mean? A radar service or an AIS service is to provide those who set up the applications with the proper data. And the one who's setting up the application is not really interested in how radar works in detail. So that's the service should provide. And he's also not interested in how the bits and bytes are running back and forth in the AIS service. So we set up services, and then we call these services data collection and data transfer services. Look to the other functions, third-party data I/O functions. Here again, we can see, okay, we have some similarities or equal functions, like data safety, firewall functions to have our system integrity in a good shape. So put all that into one service we call the gateway service. A closer look to it shows us, okay, there may be quite a lot of stakeholders who will need the same data, like voyage static and voyage related vessel data. So why not bring them all together in one physical port, this is an electronic port meant, and to don't have too much maintenance and also to save costs. Today, with today's technology, it's not that problem really. So, let's go to the other functions, the presentation functions. Again, I make some examples, and you can see traffic planning, title, slot, windows, and so forth. If we would say, okay, every application would have its own display, we pretty sure would end up in a kind of piling up of monitors in the operator side. So we better integrate this, and we also can figure out that we probably can do some harmonization and unification on these display applications. And IALA is already working on it. Okay, bring that all together in one service. We still have some user-specific applications, and that can be done today by configuration. So we can configure the access rights, the size, the number of windows, and even the number of the displays we need at these operator site. All that we put together in the user interaction service. And again, we don't want to dig too much into these technology, how to set up windows for application windows, or how to position them on a screen. That can be done by a user interaction service.